Hello, my name is Jared Girth, and I'm a solution architect in the Nokia Enterprise Business Group. Welcome to the first Tech Talks in 10 video, and the first of what will be a series on the topic of EVPN for data center networks. This video is designed as a short introduction to EVPN as a technology and why EVPN is an important part of building next-generation data center networks. I'm guessing many of you have some familiarity with EVPN, but I think it's good to establish a common baseline for this discussion. EVPN was developed as a new VPN type to address Layer 2 and Layer 3 services. The details of EVPN and its various use cases are covered in a number of RFCs, which you will see here on the screen. You'll notice that RFC 7432, for example, is titled BGP MPLS Ethernet VPN. Like other VPN types, EVPN is an address family within BGP. And MPLS is mentioned here as the data plane encapsulation, but EVPN can be paired with a number of different encapsulation types, such as VXLAN. This by itself is an important topic for data centers and something we plan to cover in a future video. EVPN was originally developed to address emerging needs in carrier networks, such as the simplicity of a single control plane for both L2 and L3 services, scalable service state and efficient address learning, improved and open multi-homing for resiliency, and flexibility for host mobility, data center interconnect, and WAN services. Data centers have many of these same challenges and therefore can benefit from adopting EVPN. Let's take a look at some trends in the data center and how EVPN can be used. Many of you will have probably built or managed networks like this. Physically, we have an access, aggregation, and core model, and there are probably large chassis deployed at the aggregation and core layers. And VLANs are used for layer 2 separation with routing between those VLANs at the aggregation layer. The layer 2 domains, or the VLANs in this design, were usually quite large and provided for relatively simple communication between hosts and easy host mobility in the early VMware environments. These networks started with spanning tree for loop prevention and then migrated to multi-chassis lag from both the server to access and the access to the aggregation tiers. Multi-chassis lag reduced the need for spanning tree and allowed for an active-active model for uplinks. Those of us that operated these networks know all too well the drawbacks of these designs. The complexity of design, the complexity of troubleshooting multiple protocols like spanning tree and MLAG and VRRP. And then there also was a weak security model, a common routing table for all of the routes, VLANs for layer 2 separation, which could easily be spoofed or just misconfigured. To combat these challenges and to take advantage of smaller, cheaper switching hardware, many networks are being redesigned to use a cloth-based fabric approach. This design promotes routing over switching and makes the network easier to troubleshoot, no spanning tree, easier to scale, and provides better uplink utilization. Fabric designs are also well suited to the increase in machine-to-machine traffic or east-west traffic. In a pure layer 3 fabric, the layer 2 domains are now quite small, usually confined to a rack. And in many situations, this creates issues with layer 2 communication and host mobility. And for redundancy, we're still using an MLAG implementation that's provided by our vendor. Routing is all done in a single routing table, and so there's still little tenant separation for routed traffic. If we use EVPN for an overlay network and build an overlay network in the data center, it allows us to keep all the benefits of the layer 3 fabric design for the underlay or the transport network, but provides us with the necessary host mobility through scalable and granular layer 2 domains. So now we get the best of both worlds, and we get to adopt the same VPN security model that we use in our WANs for both layer 2 and layer 3 services. And EVPN can also provide an improved and open multi-homing solution for end host resiliency. This could also be applied at the data center edge, so not only from the server to the TOR, but also at the data center edge. And we now have operational simplicity by using a single control plane protocol for our MAC and IP advertisements, as well as for multi-homing. Multihoming is a key part of EVPN and something that we'll cover in a future video. BGP is a familiar routing protocol, but perhaps not common in every data center, so there may be a small learning curve for some data center operators. The move to underlay and overlay networks in the data center will be an operational change, but fortunately the concept of overlay networks is not new, and there are many tools available to aid in troubleshooting. As with any technology decision, there are pros and cons, benefits and challenges. I hope you've been able to see how EVPN brings simplicity, scale, resiliency, and flexibility to next-generation data center networks. If these are challenges in your data center, I think you will find that the benefits of EVPN more than offset the learning curve of a new technology. Thank you for spending a few minutes with us watching this video. I hope it was useful. If you would like more information, or you have questions or even suggestions for future topics, please use the contact information provided here. Lastly, stay tuned for other videos on EVPN, as well as other technology topics relevant to data center networks. Thanks again for your time.